Hi folks, we're back. So hopefully you just watched this video lesson on the triangles and coordinate proofs. And now I'm going to go over the homework and maybe give you some helpful hints. So we can talk about some things together here. So this should be the yellow worksheet, I believe. These top ones should go okay. Use the pictures and the clues. Notice if it's isosceles or not. Well, it looks like they're all isosceles. I think you'll be fine there. But I'm more concerned about maybe setting up these coordinate proofs. So if we look at this one here, folks, I think you should use the same triangle as we did on the first proof in your homework. So you guys can draw that out. Quick sketch of it here. Let's see. So again, you already drew this isosceles triangle in your homework. Use a different color. We're going to get lost in the sea of green here. Thank you guys for being so understanding. I hope you're being understanding. Again, I know it's not ideal for me to be down, but we're doing the best we can. Okay, so we said A was 0, 0. B was A, comma B, C, 2A, 2B, D, 3A, B, and E, 4A, 0. So if you read what it's trying to ask us to do, the three segments joining the midpoints of the sides of an isosceles triangle form another isosceles triangle. So we have our three midpoints, and it's creating this triangle here, and we want to show, I write this down, we want to show a triangle, let's see, BDF is isosceles. So now I want you to think what makes a triangle an isosceles triangle. Two sides congruent, right? So if we look at this picture here, we would want to show that BF, this segment, is congruent to FD. So we want to show BF is congruent to FD. So that's the distance formula, okay, right? So you got to show that you get the same answer. Try it out, see how it goes. Let's do this one. Okay, the measure of the segment that joins the vertex of the right triangle of the right angle in a right triangle to the midpoint of the hypotenuse is 1/2 the measure of the hypotenuse. Okay, this is a doozy. We're all doozies. I don't know why I said that. I'm just getting nervous while talking to myself here and rambling. Okay, we're starting in the first quadrant. We have a right triangle, right? That's what it says. So lucky for us, folks, our origin can be the right angle, and we can just draw in our hypotenuse. I would use a different color. Okay. Here we go. Can you see that a little bit better? Okay, so let's see here. So we want to show that the segment that joins the vertex of the right angle to the midpoint of the hypotenuse. Here's the midpoint of our hypotenuse. How do I know it's the midpoint? Well, we're making it the midpoint. That's the beauty in these. So I know that this chunk's congruent to this chunk. We want to show that this green segment is half the measure of our hypotenuse. So now let's give these points some names here. We call that A, there's B, C, and D. We know that A is at 0, 0. For B, it's over 0, but now I'm thinking if C is my midpoint, whatever letter I use, I want to double it, right, to make our computations a little bit easier, so we'll call that 2A. C we'll say is over B up A, so it's half the distance from here to here. And then for D, let's see what kind of trouble we can get into. If this was B over, we gotta go another B to get to B, so it'd be 2B up 0. Okay, so we have kind of two things we have to first show. We first have to prove, I should probably say not show, we first have to prove, or show here, so this is step 1, folks. Show C is the midpoint of BD. So you gotta plug into the midpoint formula. That should be on the board, but if not, it's right here. Remember, you add your x coordinates, divide by 2. Add your y coordinates, divide by 2. That's step 1. Once you've done that, to show that C is the midpoint, we want to show, now your second thing you gotta show that AC, that green segment, is half the length of our hypotenuse, which is BD. So that's talking about length, right? So that's the distance formula. So plug into the distance formula, and when you're done simplifying, AC will be half the length of BD. Okay? You guys try that out. Okay, let's flip it over. If we look at these, it says draw a triangle XYZ and find the slope of each side of the triangle. Determine if the triangle is a right triangle. Explain. Well, they're giving you the ordered pair, so that will make drawing much, much simpler. So that's step 1. Step 2, determine if it's a right triangle. How do we do that? If it's a right triangle, 2 sides will have opposite reciprocal slopes, right? Because that will give us a right angle if they're perpendicular. So you have to use the slope formula. Okay? You're using the slope. Let's see. Midpoint to the side. Okay. I think you'll be okay there. On this one, draw this out. That's my hint. Draw a picture. These are the midpoints of the sides of a triangle. So these are the middle. They're not the vertices. You got to figure out what the vertices are, giving one is at the origin. So start off with a picture and it'll make the rest much, much easier. And then when you're done, you have to show what the midpoints are. So we have to show that the midpoints are true. So when you plug into the midpoint formula, you should get these as your answers. The next one's multiple choice. I think you guys can reason yourself through that and try your best on the bottom, okay? I know I probably talked way too much today, and I know you're probably half asleep. Try your best on this worksheet. We will fix all of our problems of the last 2 days when I'm back tomorrow. Please be good for the subs. I miss you already. And tomorrow will be here before we know it.